अस्सलाम वालेकुम। सो आज जो हमारे पास क्वेश्चंस हैं ये सारे के सारे हमारे पास आईकेएमसी के क्वेश्चंस हैं, मैथमेटिक ओलंपियाड के क्वेश्चंस हैं। सो हम इन्हीं क्वेश्चंस को आज ज़रा देखेंगे कि किस तरीके से हम लोगों ने इनको सॉल्व करना है। तो पहला हमारे पास जो सवाल आता है वो आता है, व्हाट इज़ द वैल्यू ऑफ 7777 स्क्वायर डिवाइडेड बाई 5555 मल्टीप्लाइड बाई 2222। अब इस क्वेश्चन को हमने जो है विदाउट द यूज़ ऑफ कैलकुलेटर सॉल्व करना है। कैलकुलेटर जो होता है वो अलाउड नहीं होता हमारे पास ओलंपियाड्स में। सो लुकिंग एट दिस क्वेश्चन विदाउट द यूज़ ऑफ कैलकुलेटर, द ओनली वे आई थिंक इसको सॉल्व किया जा सकता है इज़ कि हम जो हैं इसको अगर सिंप्लीफाई कर सकें कुछ करके। नाउ टू सिंप्लीफाई दिस, लेट्स सी कि क्या हम लोग इसको इसको और इसको एज अ फैक्टर ऑफ समथिंग लिख सकते हैं या नहीं लिख सकते। मीनिंग कि इसको मल्टीपल ऑफ टू थिंग्स क्या लिख सकते हैं हम या नहीं लिख सकते। अब यहाँ पे एक चीज़ दिख रही है मुझे, सिमिलर डिजिट्स जो हैं वो रिपीट हो रहे हैं। सिमिलर डिजिट्स हमारे पास कब रिपीट होते हैं, एग्जांपल्स हम देख लेते हैं। 11 है हमारे पास, 22, 33, 44, 55, ऑल ऑफ दीज आर मल्टीपल्स ऑफ 11। 11 मल्टीप्लाइड बाई 2, 11 मल्टीप्लाइड बाई 3, 11 मल्टीप्लाइड बाई 4 एंड सो ऑन एंड ऑन। सिमिलरली आई थिंक इसको भी हम लोग कुछ इस तरीके से ब्रेक डाउन कर सकते हैं। सो लेट्स सी कि क्या हम इसको भी कर सकते हैं उस तरीके से ब्रेक डाउन। सो 7777 जो है, लेट्स राइट इट डाउन इनटू इट्स डिफरेंट प्लेस वैल्यूज। द फर्स्ट वन 7000, this 7 can be written as 7000 plus the second one can be written as 700 plus the third one can be written as 70 and then the last one can be just written as 7. So यहाँ से the next thing that I am seeing here that I can do here is I take 7 common and inside the bracket I'll have 1000 plus 100 plus 10 plus 1. So this is something that I can see, and in the next step I can just add whatever is inside the bracket, making it 7 times 1111. अब जो चीज़ मैंने 7777 के साथ की है, I can do the same thing with 5555 and similarly 2222, right? So let's just do that. 5555 can be written as 5 times 1111. 2222 can be written as 2 times 1111. Okay, so now let's simplify this by substituting our factorized forms there. Okay, so what we have is 7777 square divided by 5555 multiplied by 2222. I can write this down as 7 times 1111 whole square divided by 5 times 1111 times 21111. अब using the property of multiplication हम इसको इधर मूव कर सकते हैं, देन 2 को इधर मूव कर सकते हैं. That's the cumulative property of multiplication. So this will become, in the numerator, the square will distribute on the both of them. So 7 square times 1111 whole square divided by 5 times 2 times 1111 whole square. This will become, we can cancel these two out, making it 7 square over 5 times 2, which is 49 over 10. So our answer here will be 49 over 10. Now let's move to the second question. So essentially, let's quickly jump on to the question number 1 again. So here, since I knew, यहाँ पे एक build किया मैंने अपना जो thought process है on the basis of the knowledge that I knew. The knowledge that I had was that similar numbers are a multiple of 11. So similarly, this must be multiple of something, and as we can see, it is just a multiple of 1111. Okay, and then I can just simplify it. Now let's move to question number 2. Julia rolls 5 dice. She rolls 19 points in total. What is the maximum number of sixes she could have rolled? Now, to roll 19 points, you have 5 dice. Let's say that the maximum number that she can roll is 3 sixes. So if she rolls 3 sixes, that would make 18, and then there's only 1 left, right? 19 minus 18 equals 1. So there's only 1 point left and 2 dice left. So 1 point on 2 dice, that's not possible. So that means she cannot roll 3 sixes. Rather, she would be rolling 2 sixes, which would be resulting in 12. So 19 minus 12, remaining we have 7, and 7 can be distributed onto, let's say, 2, 2, and then 3. Okay, so that's how much sixes she will have. She will have 2 sixes maximum, because they're talking about maximum number of sixes she could have rolled. She could not roll 3, she cannot roll 4, that would go overboard. She can roll 2, so 2 would be our answer here. Now let's look at this question. This might seem a little much difficult question, but it's actually a relatively very easy question. So here, a cylinder can has height 15 centimeter. So they're saying that this height is 15 centimeter, and the perimeter of the circular base is 30 centimeter. They're saying perimeter, not the circumference, but they are actually the same thing. Okay, so the circular base's perimeter would be 30 centimeter. An ant walks from point A on the base to point B on the roof. Its path is either vertically upwards or horizontally along the circular arc around the can. Its path is shown with a thicker line. Black is the path in front of the can, and the gray is the back. Gray is at the back. What is the length in centimeters of the ant's path? So now let's see. Ant moves up, then it moves in a circular way, then it moves up, then in a circular way, then up, then in a circular path, then up, and then in a circular path. So here we will apply the same technique that we usually apply on trying to find the perimeter of this shape. So in this case, let's say this is 10 centimeter and this is 4 centimeter. Okay, so that means this is small part, let's make it 9 centimeter. Okay, so this is small part plus this is small part plus this is small part. So this one, let's change the color so that it is much more easily understandable. So this part, and then this part, and then this part right here, all of this when combined will give us 9 centimeter. All of these when combined will give us 9 centimeter, as you can see. Okay, and similarly is the case with the above one. This part plus this part plus this part, all of this combines to make 10 centimeter of length. So we will apply the same logic here, that being that this height, then this height, which is in fact this height, if you can see, it's the circular way at the back, so it's the same. Then this height, and then at the end this circular path at here. So in total the ant has walked up straight up 15 centimeters. Now let's see how much it has moved in a circular path, because the same logic applies on the circular as well. So no circular path was moved here. After that it moved the circular path. Let me change the color so that it's more easily visible. So let's have the blue. I think blue is more easily visible. So yeah, from here it moved in a circle, then moved in a circle, then moved in a circle, then it moved in a circle again. So in total, if I look at the amount of revolutions or rotations that it has taken 1, and then it has taken 2. Since it has moved around 2 times, that means it has covered 30 centimeter twice. So the total distance the ant has traveled will be 30 plus 30 plus 15, which would make in total 75 centimeter. So our answer here will be E75. Now let's move to question number 4. Emma has 4 different colored pens. She wants to color the 3 striped rectangular flag shown in the diagram so that each strip is a single color and no 2 adjacent strips are the same color. In how many ways can she do this? So she has 4 different colors. Let's select some colors so that it becomes easy for us to visualize. So let's say that she has yellow, and then she has blue, she has red, and she has let's take orange, and let's say she has orange. Okay, so now she needs to put them 1, 2 and 3 such that no 2 stripes adjacent to each other have the same color. So that means that if the first one is orange, then the third one can be orange, just that the middle one cannot be orange. So let's see how many different ways we can write this type of coloring. So let's say the first one is orange, the second one is blue, while the third one is, let's say, orange again. Okay, orange, blue, orange. Repeating the same pattern, we can have orange, blue, and then red, orange, blue, and then red. And similarly, we can have orange, blue, and then yellow, orange, blue, and then yellow. So this is just with orange, blue, and then this. Now the same pattern would repeat such that orange, the next one would be our red, and then again orange, red, yellow. Similarly, we will have orange, and now the second color would be yellow, and then the third color would be orange, red, and blue. So looking at it, I can see there is no other way, no other pattern that is left, since I have exhausted all my options for orange, right? Orange, from orange to blue, then to orange, orange, blue, red, orange, blue, yellow. Then the next one is orange, red, and then orange again, orange, red, and I would have to remove red here and it should be blue here. Okay, so orange, red, orange, orange, red and blue, and then orange, red and yellow. Similarly, orange, yellow, orange, orange, yellow, red, and then orange, yellow, blue. Now red cannot be here because two same color cannot be in a consecutive. Okay, so there is no other pattern left where the first color would be orange. Okay, where the first color would be orange. We have exhausted all of those patterns up now. So that means when the first color was orange, we had 3, 3, and then 3 different possibilities. So just for orange, we have 9 possibilities. Similarly, I can see that, let's say we talk about red now. With red, we will have blue, and then with blue, at the very end, we can have orange, we can have red, and then we can have yellow. What I'm seeing is that the same pattern would happen, would repeat, just that the middle one would now be changing from blue to yellow, then from yellow to, I can change it to orange. So 3, 3, and then 3. So that means when starting with red, we will again have 9 different possibilities. So even for red, we have 9 possibilities. Then for blue, the same would be the case, and we'll have 9 possibilities. And then with yellow as well, we will have 9 different possibilities. So in total, we have 9 plus 9 plus 9 plus 9, 36 different possibilities. So the answer here will be 36. So this would be the part 1. Now let's continue with part 2.